All right, so I think we'll just get started. So yeah, apologies for the weird format. As I mentioned in the email, we now have child number two. It was born last week, and then I also underestimated how much time I would have last week to post something. There will be a lecture posted um, to make up for last week. Um, it'll just be it'll be something that is optional in the sense that it'll be interesting, but I won't ask anything in it from it uh, in the midterm or in the final, just so that you guys don't have to watch or do two lectures in 1 week. But yeah, so next week should should be back to normal. We'll have an in-class session, and then we'll go from there. And finish the semester as usual. So yeah, let's and yeah. So I don't know exactly. So yeah. So I'm having some flashbacks to the COVID times with Zoom. I'm assuming uh, everyone here probably does too. So apologies for that little throwback. I'm sure there's some trauma associated with that, or happy times. I don't know. For me, mostly just sad sitting in my office and talking to a screen. So, anyways, so yeah, what are we gonna do today? Let me just move this out of the way. We are uh, so I had I had mentioned enums now a couple of times, and we never had quite enough time to cover them. So we are going to start with that today, um, and they're really cool in Swift. So we'll cover, I'd say, like 60% of them today, and then we'll see more and more as we they're everywhere pretty much. Probably actually a little bit more, maybe like 80% today. So yeah, enums. We are going to look at functions as arguments to other functions. You might have heard these as callbacks. This is yeah, that's another name for it, or closures. Um, I'll maybe just write it down here as functions as arguments. We have already seen them. They were just hidden. They're everywhere in Swift UI. Um, and so they are one way of doing asynchronous work. We're doing something in one place. Something else should finish while we're doing this, and then we can come back when we're done. So this is one of the tools for asynchronous work. We will do a good amount with this. So we'll do UI work with this. We'll fetch something from the internet with this, and we'll learn lots of other fun. No, we'll learn lots of other fun asynchronous tools here. Um, maybe a couple to mention here. So Swift recently, a couple of years ago now, gained a new paradigm for doing asynchronous work, async await. We'll cover that. And there are some functional reactive ways to do asynchronous work. If that doesn't ring any bells right now, what that means, don't worry about it. We'll cover it. But in those, we are listening to streams. We're subscribing to streams, and it's a cool way to do it. So we'll cover lots of different techniques. But yeah, so functions as arguments. We'll start with that today, and then we're gonna as so last week, or the week that we had last lecture, we started kind of cementing what it means to be a delegate, or to delegate work. So we'll use a concrete example in UIKit to use delegation. So we alluded that briefly. We alluded at that briefly, that the UI table view uses the delegation pattern. So we're going to build a little to-do app. And then we'll come back to this to-do app in a couple of weeks when we cover database access. So this one will just save things in memory, and then much later we're going to come back and we'll we'll hook this up to a database. So yeah, and then say I guess to-do app, UI table view in particular we're focusing on, and so this one, the reason why we're focusing on that is we're using delegation. All right, so that is today's agenda, and so we'll just start with UI. So we'll start with the enums. I'm realizing, so I'm forgetting all the things that one does in Zoom. I don't have the chat open, so let me open that real quick. Let me move that here. There we go. So there's a question. There have not been any video lectures for week 6. Yes, I mentioned that at the beginning. I overestimated how much time I would have in this first week. There will be a lecture uploaded. It'll just be optional to watch. It'll be interesting, but it won't, hopefully, but it won't be material covered on any of the exams. It might help you with your app. Okay. Great. So yeah, feel free to use chat as a way to let me know that for questions or anything else. Feel free to unmute yourself and ask a question directly. But yeah. All right. So let's start with enums, and let's. Oh, Xcode went over here. Let me just close that. Let's see if I can open it down here. Oh, hot corners. Close Xcode, bring it up, hopefully here. Please open. Did it open in a funny place? Let's see. There we go. Okay. So let's start with just. I think one of the reasons things are slow right now is because of QuickTime taking up resources for screen sharing. So I just turn that off for now, and we'll bring it back as needed. So let's start with a playground. I think there's a lot of the enum work we can do with playgrounds. And so yeah, let's start. We'll name this here we go, enums. All right, and I have too many things open. Okay. All right. So, what might you know from enums in other languages? So, in a lot of other languages, they are a convenient way to restrict the integers. So, for example, if you have if you were to use all of the integers for certain applications, there might be some errors that get introduced. So, for example, let's pick days of week. So days of week can be easily represented with integers. Maybe we start with 0 and go to 6, so Monday through Sunday, or if you'd like to start your weeks with Sundays, then we go from Sunday through Saturday, 0 through 6. But yeah, what does it mean if it's outside of this? So I guess we could go negative, so -1. One way to avoid that is we can maybe use unsigned integers, so that's already an improvement. We cut down the potential input in half. We got rid of all of the negatives, negative numbers, but yeah. So there's still. What does it mean if I use the number 9? What day of week is that? So it doesn't make a lot of sense. So how do we make it that you can only use the numbers 0 through 6? So enums in other languages restrict, or take one larger set, the large set of integers, and you can kind of define your own type. You can say, okay, I only want Monday through Sunday. So we can do that in Swift too, and maybe we'll start with that. I'm assuming most of you have seen enums in that way, or enumerations. So let's do that. Let's see what the syntax is like, and then we can go from there. So we start with the keyword enum, and then we'll do day of week. Okay. So day of week, we have so in Swift there are cases for each of these. So maybe we have Monday. If you look at really old Swift code, there the cases start with an uppercase. You won't see that in new anything more modern, and we'll see in a second that it kind of looks weird if the cases start uppercased. So, but by conventions, they are all lowercase. And let's maybe get a lot of the other syntax out of the way. So we theoretically we're creating a case for each of these. So Monday is a case, Tuesday is a case. We could list them like this, comma separated, or we could do new line for each of these. And we'll choose this one for now, because there's some extra things that we can do with enums that is a little bit easier to understand if we're creating a case for each of them. We do Thursday, and Sunday. Okay, so we have now our type day of week, and there's only 7 of these. So there's 7 things that we can create. So if we used integers, we could create up to max int and min int. So lots of individual versions of this. Here we can only create 7. How would it look if we, so that maybe we have I'm just going to abbreviate this one, day of week. That's my variable name here. I'm going to create a day of week, and I'm going to say I want Monday. Okay, so that's how I would instantiate a Monday. A nice thing about enums, if you know the type for a variable, or in this case a constant, we don't have to write the full name of the enum. We can just do period and then Monday. So it's short for day of week dot Monday, but even the autocomplete will know what you're trying to do here. So if I just do period, it knows the cases that I want to do here. And you have seen this in lots of places. We've already seen enums where maybe you were confused why is there a period in front of this thing? So we're dealing with an enum, and here there's not much. It's not much simpler because here we have the type right here. But let's say we have a function that maybe prints the day of a week. So print day of week, and then maybe here we have our day of week, day of week. So if you were to call this function, we can now just do Monday like this, because the parameter that we have here is known as day of week. And so there are questions. I didn't see it so far. Sorry. Okay, so there's something about the final project. I'll get to that a little bit later. Midterms, we'll get to that as well. Apologies, and then more midterm questions. So I'll get to that maybe right before the break. I'll cover that. But yeah, so this I find pretty nice to read. There's less clutter than here. It's simpler to parse. So I find this very, very nice. And yeah, so here it used to be that you would then have an uppercase here, but kind of in all of Swift, uppercase means you're defining uppercase at the beginning. You're defining a type, and this is not a type. This is something on the type, or like a something about the type. So here we have the Monday version of that type. So I think this was a good change. But yeah, so you might still see an uppercase there. All right. So yeah. So far, I'm assuming we've only mostly covered syntax that might be new, and so yeah, it goes a little bit more. There's so much more here than what other languages can do. So we are not quite on. We don't quite have parity with something that is an enum in another language, where we're restricting the integers to with an enum. So in this case, we have an enum that doesn't have an underlying type. That's how we've defined it. So this one is actually not an integer-based enum. We can do that though. So if we say this enum should be integer-based, we now pretty much have parity with other languages that use the integers for enums. And yeah, so where does this matter? So what I can do now is, here, let's turn this day of week into a variable. What we can now do is we can say I want to create a day of week, and we now have this new constructor that we were given just because we're saying we're integer based, and here we can type in a raw value, which is an integer. So we're integer based. So let's say we want to create a day of week from the integer 0, and so alarm bells should go off. We're going from the integers, which is a really large set, down to a set of just 7 values here. So the integer initializer that we get for the integer-based enums, if we command click, I guess I think we won't. Do we get it here? We don't get it here. Yeah. So it is a failable initializer. So this, just like the double, where we can create a double from a string, an integer from a string. We're going from a much larger set to a much smaller set, so this can fail. A couple of things we can do here. So we could make a day of week optional, which is in this case then not what I want necessarily here. I want to be able to have. I don't want to have to check for optionality each time. So one thing we can do, and I think we haven't covered this yet, is I'm going to cover the nil coalescing operator here. So let's say if this fails, I want to have a default value that gets assigned. The nil coalescing operator is 2 question marks, and then I can give a default value. So if this fails, we then provide this one. This is not something that is specific to enums. I just wanted to give you guys that operator here. It's useful in a lot of places where you can give a sensible default. If you can't give a sensible default, we would want to be working with an optional. All right, so we've created a day of week from an integer. I guess right now Monday and 0 would be the same one. Let's just go with 5 here, so just so that we get something else. And let's print our day of week. So let's see what we get here. So let's print it. Let's get it to the console, and let's see what we get there. So didn't change it to. It might still make sense to change it to macOS, just to save some time, because the compiler doesn't, the emulator doesn't have to start up. So let's see. I think this is still faster. Okay, let's see what we get here. So we're printing day of week. So in your head, what should 5 correspond to? Um, it should correspond to Saturday. Why are we printing Monday? That's a good question here. Let me see what I'm doing wrong. So we have Monday here. What is going wrong here? We're printing Monday. Why are we printing Monday? Oh, because we're printing Monday. We want to print day of week. There we go. But yeah, in the gutter here, we already saw we're printing Saturday. So let's see how this corresponds to what we're understanding about enum so far. So if it's 0 indexed, so let's start with 0, 1, 2, 3, 4, 5. So, okay, so the enums that are integer based in Swift seem to be 0 indexed. What if I don't want that? What if I want to have Monday start with 1 and Sunday go to 7? Maybe that's a little bit easier for me to think about. Very simple to do in Swift. I think here we're already at a point where other languages, it's a little bit harder or maybe impossible. I can just say Monday should be 1. And now if I call our print day of week function, we get for 5, what do we get? So 1, 2, 3, 4, 5. We get Friday instead. So that's nice. And maybe I like starting my my weeks with Monday. I've never quite understood why people like starting them with Sunday, but maybe that's what you like. So we could do that without rewriting anything here. So let's start our enum with Sunday. Let's say this one should be 0, this one should be 1, and we can still do that. So we don't, wherever we want a special value, we can assign it. Let's do 0. So we should get Sunday for that one. There we go. We get Sunday. So you can just assign all of them if you want. You can if you assign one, the ones that are following will just increment by 1, and you can create gaps. So maybe you want them to be the odd numbers, maybe for some reason. I don't know why you would want this, but you could, and maybe we'll keep Sunday. So now let's do 7. What is 7? 7 will be Thursday, hopefully. There we go. So yeah, we can kind of do whatever we want. You might wonder, why would I do that? That seems silly. So yeah, for days of week, this is silly, and I'm going to undo this here real quick. But for example, so one place where we're using enums is with errors. So maybe you want to have a specific error code associated with a specific enum. So there it makes sense to be very specific with which one is which. And then yeah, you might not have all of the integers represented. Maybe you want to jump to maybe match server errors or something like that. So there it makes sense to have some gaps or have them assigned each individually. Okay, so yeah, enums in Swift can be pretty much what you're used to in other languages. It can cover the integers. I guess one thing we haven't covered is how do I get back to the integer value. So here we have let's maybe create another function. So print day of week, I guess raw value. That's kind of silly. We don't need an extra function. So let's just print straight here our day of week. So if we print the day of week, so we saw that we get the name of the case that we have up here. If we want to go back to the integer representation, since we're integer based, we kind of do the reverse of the creation of the integer based enum. We are trying to access the raw value. So day of week dot raw value will give us back the integer representation. And no need to have an optional here, since we're going from a smaller set to a much larger one, so we get that one back. Okay, so yeah, I think by now we have mostly covered everything that you would see in another language with enums. Maybe, so yeah, one really nice thing of restricting the set of days of week. So one, we can only create these that are here, so that's very nice. We can iterate over all of them. So maybe I want to, let's print all of the days of week here. So how do we do that? So we have to conform to a specific protocol that allows us to iterate over them, to go from one to the next to the next to the next. So the protocol that we have to conform to is called case iterable. Case iterable. There we go. So we don't have to do anything for this. It just does its magic behind the scenes. And now what we can do is for day of week, we're gonna loop over all of them. So we're gonna take all of the days of week, and there's an all cases property on there. So what does that look like? This all cases property. If we go, I guess, so in the playground we can't see it. So the all cases, so if we assign it to its own, yeah, let's just create a temporary variable. What is this all cases property on our day of week? If we go there, it is an array of days of week. So we have just an array of days of week, and it creates that for us. And yeah, I don't think we've seen this loop before in Swift. So if you want to loop over an array, and you don't want to deal with an index, we can go over each of the elements in this array, assign it to this local variable here, and then we have access to it in our bracket. So this is, I'd say, the most Swifty way of looping over something. Most of the time, you are looping over something where you want the content and not an index. So it's a really nice way to do it. And I think I'm seeing a question here. So yeah, all cases show up because of case iterable. Very good. So if I were to remove this, we're going to have a compile time error, and this won't work anymore. So it has no all cases thing there. And you might wonder, why do I have to specify this? That seems silly. Don't I always want to iterate over my enums? No, there are some enums that you could create that are impossible to iterate over, and we'll get there. So not something that you'd be able to do in another language, but we can create enums in a way that it would be impossible to iterate over all cases. All right, but yeah, so let's iterate over these. Let's just print them out. So we'll just print out day of week. So yeah, this is one reason why you might want to create an enum. You want to be able to, didn't realize that this was all up here. You might want to be able to, yeah, do something with each one of them. You might want to, here we go. There we are, we're printing all of them. You might want to make sure that you're not creating something that is not representable as a day of week. So then you would have to check first that whatever you created is a valid day of week. So yeah, what else? You might want to have a nicer way of representing whatever you're talking about. So if I'm talking about day of week 0, if I'm using the integers, there might be some confusion. Are we talking about Sunday or are we talking about Monday? So depending on who you talk to, 0 might be Sunday or Monday. Or if I'm talking about 1, it could be the first day if we're 1 indexed, or the second day if we're 0 indexed. So it just gives us a neat way to talk about the thing that we're using. It just reduces mistakes. There's another really nice thing that we have access to if we're using an index, if we're using an enum. So let's say we have so right now we have these ways of representing the enum by just printing it. So it's Monday through Sunday. Let's say we want to create a shorter representation of it. So maybe we want to be able to say like a 2-letter short version of this. And we want to print that out. So we want to do something with each of our possible days of week. And we don't want to miss any of them. So we don't want to forget about Sunday. And we don't want to accidentally cover something that's not a day of week. So there's another control structure. So we saw the for control structure today. There's another one called switch. And what the switch control structure does is whatever you pass to switch. So I'm going to pass the day of week that we created here, or our variable up here. I'm going to pass day of week to our switch. And we're going to do something for each possibility that day of week has. So a switch statement, if you haven't seen it in another language, is an if-else block, where you're covering everything that is possible. To do the same, what we're doing here with if-else, it would be like this. If a day of week, I'm going to do it with the raw value, is 0, then let's maybe print, I think we had it Sunday. I guess we want it shorter. So Sunday, else if, and I'm going to do some copy paste here just to make that a little bit easier. So I don't know how many I need here. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so we only need this. And then here we'll do 1, 2, 3, 4, 5, 6. Okay. So if we want to do something for each possible value, so we could write an if-else block like this, or so this is kind of hard to read. I don't know if I see this and I have 100 cases. It's kind of hard to know if we've covered all of them. So what the switch statement allows us to do is the compiler will make sure that we cover everything, which is super neat. So I can just say, I just said I want to switch on day of week. Day of week is an enum that has 7 possible cases. I'm going to click here and say fix. I'm missing some cases. So switch must be exhaustive, meaning every case that it can be has to be covered. So let's click on fix, and the compiler knew what was missing and gave me all of the missing cases, which is pretty cool. So let's just do the same thing where we just take all of these. I'm creating multiple cursors. You can do that with Shift, Control, and then clicking. And then if you do Shift, I think it's Option, you go from token to next token. Here we go. Sorry. Here we go. So I'm going to copy that, and then I'm going to create multiple cursors again by highlighting this with Shift and Control. And I'm going to do Command Paste, and we have something for all of them. Okay, so this should. I guess I have them. I have them misaligned. Let's do. What does it start with? Sunday. Okay. Well, let's move this one down. I think I can do this, or not. No, I'm getting myself. Whatever. Let's. What am I starting with? I'm starting with Sunday. Here we go. Let's do this. Okay, I am unable to type. Okay, let's do this again. So Control Shift gives me multiple cursors wherever wherever I click, and then I can, so if I just hold down shift, these are all the same length, I can just do this, copy, and then I could even go down and paste here. Okay, so does the same, so these two do the same thing. This if else block, and this switch statement. The nice thing with the switch statement is I know that I covered them all. Here I would have to manually go through and make sure that I actually covered them all. If I'm deleting one here, the compiler will complain. So kind of the same theme that we've covered in the past. Whenever the compiler can help us, that's the ideal. We don't want to have a runtime error. We want the compiler to help us. All right, so yeah, switch statements, very useful when you want to do something for every single element. We're going to see different versions of how you can cover every case. So we'll see that in a second here. But yeah, so whenever you can, have the compiler help you. So I'm actually going to, I guess we can leave it for now, but yeah. All right, so yeah, we have now, I think we've covered all of the traditional benefits of using an enum, maybe a couple that are unique to Swift, and but result from us using an enum, meaning the compiler being able to help us. So wouldn't it now be nice? So to me, like the shorter representation belongs to the day of week type. So this, if I were to have this day of week type, maybe I'm creating a library with day of week, wouldn't it be nice if I had like a shorter representation of the day that can be printed? Wouldn't that be nice, without having to maybe wrap this into a function? So we could wrap this into a function. We could say short string for day of week, and then we'll return a string, and then instead of the print statements we will return something. Okay, so yeah, we could have this as an extra function that we ship our day of week with, but it's not discoverable. So if I type day of week, so if I have a day of week, I can't. So I have a raw value representation that I can access. This is not discoverable. So I would have to go through the documentation. How do I get a shorter representation of my enum, and find this function that is part of this library? So wouldn't it be nice if I had a function on day of week that was just short string? So day of week short string, wouldn't that be nice? And then that printed out, or that gave me the short string representation. We can actually do that with enums. So how would we do that? And this is where things become strange if you're used to enums from other languages. We can take this function. You can take this whole function, and I'm gonna just add it to the enum type declaration. So I have my enum. The type declaration starts here, ends here. We have our cases, and now we have this function on the enum, and we actually don't need to pass in a day of week anymore, because we can call this function on an enum instance. So we know what we're talking about when we're calling this. We're calling switch on self, and if that's confusing, let's take a look at where we're calling this. So day of week is a variable that we've defined ourselves, and on this variable, maybe it was Monday, we want to get the short string representation for Monday. So we want to print out MO for this thing. So for the Monday day of week, I want the short string. So here we have our enum, and then we have this function on the enum where we can switch on ourselves and then return the shorter string representation. So let me know if there's any questions here. This might be very new, which is understandable. But so let's see it in action. Let's see it in action, and let's see what that looks like. So we'll just print this, and I guess we're doing a lot of printing. Let's just get it into the gutter here. So day of week short. There we go. So that should give us a little gutter representation of that thing. My cat is being fed through the door right now. I had accidentally locked it. All right, so yeah, we have our short representation of the day of week here in the gutter, and so that's nice. That's very discoverable now. So if I do day of week dot, I have short string, very discoverable, very nice. So to me, it would even be nicer. So if we're looking at raw value, so the raw value representation is a property on day of week. Wouldn't it be nice if short string? So to me, this doesn't seem function-y. This seems property-like. So wouldn't it be nice if I could just do short string, and this would be a property on our day of week? We can do that very easily. We can instead of having this be a function, so we know that functions can be of on enums. We can also have what's called computed properties, and I think we've briefly covered them. So we can have a computed property, which is we're saying we have this property here. We have a short string property, and then instead of providing a value, we add a function body. So our enum now has a property, short string, that gets computed based on what that day of week is. So just to demonstrate that this still works, so we are recompiling this, and it'll still say Sunday here in a second. And so we can do I guess yeah. So we don't have to stop here. So short string, maybe we want to know if so to me it might be useful if I'm dealing with a day of week. It would be maybe useful to know if it's a weekday or a weekend day. So wouldn't it be nice to have something like this? It's weekend, so maybe we're interested in that. So day of week, and then again, is weekend day, maybe like this. Wouldn't it be nice if we had a property, or I guess maybe just is weekend. Wouldn't it be nice if we had a property on day of week? So we'll have a compile time error here in a second because this is not a property on day of week right now. But wouldn't it be nice if we had that? If we knew just by having it be discoverable by hitting the period, and then I can quickly find out if this is a day of week or is weekend. So let's implement this real quick. So we can have as many functions or computed properties on enums as we want. So let's create another computed property. So is weekend would be a Boolean. And then we can do the same thing where we switch on ourselves. So we're inside day of week. We're switching on ourselves. The compiler will help us. Here we go. Switch must be exhaustive. Fix, and we get all of our cases here. So let's. So for is weekend, we actually don't need all of these, right? So we just need to know that for Saturday and Sunday, that these are true, and everything else needs to be false. So let's first of all, we'll kind of work ourselves to not needing all of these here. Let's see a couple of ways that we can write switch statements where some of them are equal. So Saturday and Sunday, they should both return true. Here, let's maybe just implement it first. So those should return true, and then these should return false. Oh, there's another interesting fun thing. So if you're trying to replace the same thing over and over again, I can do Command E. That kind of copies whatever I have highlighted, and then I can paste. And then if I do Command G, it goes to the next representation of that thing. So I can do now V, G, V, G, V, and then it just does all of these. So Command E selects something. So if I want to select false here, I can do Command E. And then if I do Command G, it goes to the next representation of that thing. Very useful. Okay, so yeah, is weekend. We now have that implemented. We'll clean this up in a second. Let's maybe just see that this works. That this works. So I forgot what we had in there. Sunday. So this should be true. And then is weekday. Yeah. So let's do here. Let's do this. Let's update our day of week. Let's set it to Monday, and then let's update is day of week, and then we should see true in the gutter here for Sunday and false down here. Okay, so very nice and very discoverable, because now I can hit period and I have is weekend. Very nice. All right, so let's make this a little bit easier to read. So here we can't really go shorter than this. Apologies, my cat wants out. 1 second. All right. So so yeah, here we can't really go shorter. Here we can go much shorter. So the first thing we can do is we can group like return statements. So Saturday and Sunday should maybe be the same one. So we can just comma separate them. Very good. And then so the other ones should as well. So we can just comma separate these. And here again I can do Command E for this whole thing that I want. And then I type comma space Command G going to the next thing. And then I can do this a little bit quicker. Okay, so this does the same thing. We now have Monday, Tuesday, Wednesday, Thursday, Friday, return false, and then Saturday and Sunday, return true. I actually think this is probably the nicest implementation, since it's still very clear which one does which. But so we could also do something like this, where, and maybe we'll implement it for is weekday. We could now just do the reverse here, so not is weekend. So that would be a perfectly fine implementation of is weekday. So we could do something like this too. So we only want to return true for Monday, Tuesday, Wednesday, Thursday, Friday. And then if that's not the case, so if we just remove that, we're running into switch must be exhaustive, we can have a default. And for the default, we'll return false. So sometimes this is necessary. You can't cover, so if you have something that's much larger, if you're switching on something that's much larger than the 7 items that we have here, maybe you're switching on a string. You can switch on a string or anything, not just an enum. So then you have to have a default clause to catch everything else. Here, having a default clause for just 7 items, I don't like that much. Maybe we're so for days of week, probably not, but maybe we're adding another case. Maybe Sunday special. I don't know. So now this one this one doesn't catch it. This one does. So here the compiler helps us. Down here, it does not. But yeah, so these are a couple of other ways that we can do the same thing. Yeah, anyways, so very nice. We can have properties on our on our enum. And then so one other thing about like printing the enum itself. So the first thing we were doing when we were printing it out, we just printed the enum, and it gave us the string representation of this. There's one downside of working with the raw enum cases. What if you introduced another language? Maybe we wanted German. So then Monday would be Montag. So I would want that to print and not Monday. And so here I would want to have it print instead of Sunday. I would want to say Sonntag, so SO. So if we have a string representation, we can internationalize strings. So this is fine. We can't internationalize those cases here. So whenever you're printing a string representation of an enum, I would say just create another computed property. And then, so maybe here we'll have long string. And then, in this case, we can just copy all of these and paste it in here. And then we have the same thing, but then now we could maybe we would want this to be uppercase. Maybe we would want to have the ability to later internationalize and translate this. So it's nice to have a special property for that. Something that I think makes sense if this is kind of the main representation of your enum, there's another protocol that we can adhere to called custom string convertible. And what the custom string convertible protocol wants is the only thing that we need for that one is the description. So we just need to have a property that is a string that says description, and we can fulfill that with a computed property. So maybe instead of long string, we can say description. And then so now wherever we were, so let's rerun this. And wherever we were printing our enum, we now are printing the full custom string representable version, so our description. So just as a little advice here, whenever you're printing or showing to the user an enum representation, I would use this custom string convertible. If you're printing straight with the print statement, or if you're adding it to if you're string concatenating, so maybe something like this. It is. So if you're adding the day of week in a string like this, it will pick the custom string convertible for this one. So if we rerun this, it'll now say it is, and then our description version of our. So it is Monday. So it picks the custom string convertible. I'm realizing I have these messed up again, so I'm not going to spend time fixing this right now. I have them not ordered the right way. All right, so yeah, we have a way to create string representations. We have a way to create short strings. Maybe your server is 0 indexed and starts with Monday. Maybe in your code, for some reason, you have a different representation. You can create a computed property that says server integer or something like that. So all of these things you can have on the type directly. They're discoverable when you're typing the dot. So now we have, is weekend, all of these are discoverable, which is very nice. Okay, yeah. Any questions here? While you're maybe thinking, let me just make sure that I don't have anything else in my notes. Yeah. So again, we're dealing with. Oh, yeah. So there are questions. Great. Yes. So the question is, could you make it? So is weekend? I think I had that first. Here we go. So we could do this. That was in the questions. You could do this. Yes. I'm just trying to give you as many of the switch statement use cases here. But yeah, so for this one, we could have just done not this thing. Very good. Good question. Any other questions? Okay. So now we're going to step into the realm of... So this was all still... Okay, my cat came back in. He can open doors. I'm going to close the door again. Okay. You want to say hi? He likes, whenever I'm talking, especially on the computer, he likes to be near me, and he is trained to open doors. Yeah. So far we've been dealing with integers, and we're not limited to integers. We can do other things. So what comes to mind? Obviously, strings would come to mind. So let's maybe create another. Let's create another enum here, and maybe let's call it playing card. Playing cards. So playing cards. So we have, or maybe playing card. Oh yeah, let's start with the whole playing card. So we have. Or let's maybe playing card suit. Let's start with that one. No, let's start with playing card. Sorry. So we have maybe and let's only do. Oh yeah, not suit, but let's do playing card value. There we go. So we obviously have the numeric ones. So or I guess so it's called suit, and is it called face? I forget. Not value. I think it's not value. Maybe playing card face. If someone knows the correct term here, I'm blanking on it right now. So, and this is what I mean here. So we have maybe the ace of spades, and then so spades is the suit, and I think this is the what is this called? I'm forgetting. So this is what I'm talking about. But yeah, so we have so we have ace, obviously ace. We have queen. We have king. We have jack, and then we have numbers too. So we have 2, we have 3, and so on. I'm not going to do them all the way to 9. So we have number cards, and then I guess face cards. So here, there's kind of a mix between two things. We could use an integer, I guess, but let's use something else to represent these here. So let's have them represented by a string. So our playing card will be represented by an enum that is string based. So what does that mean? So if I'm now instantiating a playing card, I can now say, so I'm going to create an ace, or I could say, so if I create it with a string, I could say raw value, and now it takes a string, and here I can say king, maybe. So king, again, we're going from the very much larger set of all the strings to however many I've created here. So we have to have a default value or unwrap. So maybe I'll default to the ace here. So yeah, now we have a string-based enum. Kind of everything else applies that we've had before. We can create properties and functions on there, computed properties. We can assign values. Let's turn this into suit. I think that makes a little bit more sense. So playing cut suit. Playing cut suit, and then we have spades, hearts, what else is there? I'm totally blanking right now. Maybe once I see him, it'll make a little bit more sense here. So 1 second. Thank you, clubs, diamonds. Okay, so yeah, for these, I think it makes a lot more sense to have strings. And then let's update this here real quick. Thank you very much. So here it makes a lot of sense to have strings. And maybe instead of typing the name here, so we can be very specific with what the string should be, but it could be anything. So for example, if we go to our emojis, where is it here? Where is it? Emojis, where are you? I always forget. Edit. Okay. So there are playing card emojis. Oh, and it that's new. It gives me that one immediately. That's very nice. So okay, let's do this. There should be a way to just pick emojis. Here we go. So it was new that it gave me that. That was nice. So hearts, I can search for that. Heart, very good. Clubs. We can go back there. Clubs and diamonds. There we go. So yeah, these are strings that we have here. Emojis are strings; they're legal strings, and so it'll be a little bit harder to instantiate it this way. But so this one will actually fail and give us spades again. Oh, I guess we have spades here. So let's do this one. So it'll be harder to type, but our playing card suit is string based on these emojis, and then so hopefully that. So we're instantiating spades here, very good, and then we're instantiating clubs based on the raw value. So we have clubs here. So yeah, so this one is string based. Okay, useful and so it's definitely useful. Yeah, so as far as I know, not supported by a lot of other languages. So you're stuck with integers. So here we have strings. We're not limited to just that. In Swift, errors are enums. So if I want to, maybe we have a bunch of responses that our server might come back with, and we'll call these maybe a server error. I can say it's not string based, it's not integer based, it'll be error based. So this enum will be error based. And again, this is very nice because if we're to switch on an error, we are forced to cover all of them. So if we want to make sure that we've covered all the errors that we have defined, if we switch on it, we are forced to cover all of them. But yeah, so maybe we have resource not found. Okay, so that could be one case. Then we could maybe have maintenance server in maintenance mode. Server maintenance. Okay, so these are now errors that we can use. We haven't really covered. The only error handling that we've seen so far is with optionals. So if something can't be instantiated, we get nil back. There is exception handling, or in this case, we're throwing errors, and you can catch those errors. Those are those enums. Those are enums. Those are enum errors. So yeah, errors in Swift are enums. Other things are enums in Swift, where you might not suspect it. So I feel like this one's not necessarily out of left field. This one makes a lot of sense. If there's integers supported, why not support strings? There's something that is, in my opinion, completely out of left field, but also really cool. And we'll cover that, but we'll do, I want to make sure that you guys also have a little break. So let's do a 10-minute break right now. So I think it's 8:08 right now. So let's come back at 8:18. Let's do a 10-minute break here, and we'll come back and we'll cover a little bit more enums, some more adventurous stuff. So yeah, I'll see you guys at 8:19 since it's 19 now. And yeah, feel free to keep asking questions in chat. I will stop the recording here.